Okay, so today we're going to be doing tree diagrams and two-way tables. So a tree diagram has branches, and in these branches they are a list of all the possibilities of a particular outcome. And a two-way table, it's used to represent our sample space. So our sample space is any of our outcomes. So for example, it could be if we were doing a survey on 100 people, our sample space would be all of those 100. So first we're going to look at a tree diagram with tossing a coin twice. So we know with a coin, the sample space is a head and a tail for one flip. So of course for two flips, there would be two tails and two heads. Okay, so now we're going to look at a coin. We know that a coin has two sides, a head and a tail. So if we were to flip this coin twice, we would essentially be able to have the opportunity to get either, two heads or two tails, or in some kind of order. So we have our first flip and our second flip, and over here we're going to write outcomes. So when we flip the coin the first time, we could get a head or a tail. The second time, or the second flip, again we could get a head or a tail, or if we got a tail the first time, again we could get a head or a tail. So our outcomes now follow this line here. So head, head, so head, 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 tail, head, tail, tail, head, or tail, tail. So that is our sample space and all of our possible outcomes. Okay, so now we're going to look at the same data but in a two-way table. Here we have coin number 1 and number 2. Now available outcomes for both of these are a heads and a tails, and over here heads and tails. They are the only outcomes we can get. Now let's say we actually flip the coin. So the first flip we could get a head or we could get a tail. For our second coin, which is here, we could either get a head or a head over here, a tail, or a head, tail, and a tail. So if you go back and look at our previous page, the outcomes when we have all of the available outcomes, you will see are exactly the same in our tree diagram as they are in our two-way table, which is all of these ones. Okay, so here I've returned back to our tree diagram. And what I want to do now is we want to calculate the probabilities of getting two heads. Okay, so it's this one here. So our P, which is our event, so our probability event, equals the number of favourable outcomes over the total of outcomes. So in this case, because we're only looking for two heads, there's only one possibility out of the whole four. Probability of getting a head is 1 over a total of 4. Now let's look at the probability of getting a head and a tail. So in this case, there are two, this one and this one. So again, our probability of tail and head and tail, okay, is 2 over 4, or simplified 1 over 2. To work out our probabilities, it's exactly the same on the two-way table, only that I've just used a tree diagram as an example. Okay, so now we're going to do another example where we have one coin and a six-sided die, and we want to work out the probabilities of some outcomes. So we could either get a head or a tail. Now after we flip that coin, we would then go and roll the die. Now if we get a head, we could then get a 1, 2, 3, 4, 5, or a 6. Just as the same, we would get the same for tail. as you can see here. Our outcomes would be H1, H2, and so forth. Okay, now let's go back to our coin. We have a 1 in 2 chance of getting a head or a 1 in 2 chance of getting a tail. If we fast forward to our die, there are 6 sides. So for us to get a 1, we've got a 1 in 6 chance of getting it, as we do for all the other numbers. So I'm going to go ahead and I'm going to add those in. Okay, so now we've got all of our probabilities. So let's look at a probability event of getting a head and then a 1. Now for this, we have a 1 over 2 chance of getting a head times by a 1 over 6 chance of getting a 1. We've got a 1 in 12 chance of flipping a head and then getting a 1. Now I'd like you to have a practice with the following example. So here is your question. Sample space of 2 children that are born into a family that are what are the chances that 2 girls, 2 boys, a boy then a girl then a boy, and 1 of each sex? Have a go at this practice question. Good luck.